Okay, so hopefully you have looked at the discussion and you have seen what other people have written. But regardless of where you are and what you have observed, there's really only about 4 possible answers that I would think of that you could put for things that are not matter. And so we'll get to that a little bit later as we talk about what matter is and go through our discussion of matter. But I do want you to recognize that a lot of the things some of you probably put as not matter, one of the number one things that people always put is air. Air is matter. So we'll talk about that in just a moment. So let's go ahead and get started with our classification of matter, what matter is and how we classify it. So you should have your notes handout that you got from Google Drive so you can fill in, whether you printed it off and you're handwriting it or whether you are filling it in on your computer is up to you, but you should have that right now. So what is matter? Well, the definition of matter is anything that has mass and volume. Volume means that it takes up space. All right, it has dimensions. So everything else in the world is either matter or energy, which means that when you look around the room that you're in, the only things that you could observe possibly that are not matter would be light, not the light bulbs, but the actual light itself. Light is energy, and then if there's any noise going on, sound is energy. Heat is energy. So light, sound, heat, those are not matter. They're energy, but everything else in the room that you're in is pretty much matter, and that's what we're going to talk about. Chemistry deals with matter mostly, so we're going to be dealing with matter. So let's talk about it. All matter, anything that has mass and volume, can be divided into 2 broad categories. Right? And you're going to see that scientists like to break things up into categories, and usually we break things up into 2 categories. You learned in biology the dichotomous key type technique for figuring stuff out. We like to break things up into 2 categories, and then 2 categories we make these nice little trees of organization, and that's what scientists like to do. So matter is divided into 2 broad categories. One is substances, sometimes called pure substances, and mixtures. So we have matter is broken up into 2 categories of substances and mixtures. So let's talk about each one of these individually first. We're going to start with substances. All right, substances is matter that has a uniform and unchanging composition, meaning anything that has the same. This word uniform means one form or all the same. They all look the same. Unchanging composition, which means if I get something from one place in the world and it's the same as somewhere else in the world, it will be the same no matter what. Now, I happen to have here a couple of examples of substances, so hopefully you can see this fairly well. This is nickel, all right? It's a metal, but every single one of these is made up of exactly the same thing. It doesn't matter. And whether I got this nickel from Africa or whether I got it from Australia, it doesn't matter where it came from. Nickel is nickel. It has a uniform composition. Same thing with this. This is silicon. And it also, every single one of those is made up of exactly the same stuff. Everything in there is the same. And now they may not have the same shape, these rocks, but they have the exact same composition. And then here I have something called copper chloride. This also is a pure substance. Every particle of this, every crystal is exactly the same. And so no matter where I get it from, it's exactly the same. So these are pure substances. All right? They have a uniform and unchanging composition. All of the particles that make them up are the same. A sample of substance from one place will be identical to a sample from somewhere else, as I said before. If you get it from Africa or Australia or Europe or Dallas or Fort Worth, it doesn't matter where you get it. If it is nickel, then it is going to be the same as every other nickel everywhere else. Substances can also be divided into two categories. Again, we like to divide things up into categories. So those two categories are elements and compounds. So matter is either a substance or a mixture. Substances are either elements or compounds. Excuse me. So let's talk about those. What is an element? Elements are substances that are made up of only one kind of atom. So the two examples I showed you a second ago, nickel and silicon, these are both elements. They're made up of only one kind of atom. Every atom in here is nickel. Every atom in here is silicon. All right? They're made up of only one kind of atom. If something is an element, then it can be found on the periodic table of elements. That's why we call it the periodic table of elements. If it's not on the periodic table, it's not an element. So whenever I'm asking you to classify things, look, if you see the name on the periodic table, then it is an element. If not, it's not an element. All right, there are 118 elements on the periodic table, but only 94 of them that actually occur naturally on Earth. The others are man-made, and later we'll talk about why we make elements, why we go through the process of trying to man-make them. In short, it's so that we can understand how they're put together. But only 94 of them occur naturally on Earth. So there we go. That's elements. Compounds. A compound is a substance made up of a chemical combination of two or more elements combined in fixed proportions. So it's very important that you understand that they are a chemical combination. And compounds typically are completely different in characteristics from the elements that make them up. So this is copper chloride. It's made up of copper and chlorine. You guys have all seen copper in pennies. It's that nice little reddish brown metal, and chlorine is a greenish yellow gas. So you put them together chemically and they have completely different characteristics. All right, just like you are not your parents. You're not exactly the same. You don't look exactly the same. You may have some characteristics of each, but you are made up of stuff from each of your parents, and so you are different, but you are a completely different thing. So you take mom, you take dad, you put them together, you get kid. Kid is different than mom or dad. They're not the same. All right. So copper and chlorine are two completely different elements that when they are combined, they make something that is not the same as either one of them. So this is not copper. This is not chlorine. This is copper chloride. All right. There are literally millions, if not billions, of different compounds in the world. So we're obviously not going to learn every single compound that exists because that would be impossible. All right, so review. All matter is divided into two categories. Matter is either a substance or a mixture. Substances are either compounds or elements. So now let's talk about mixtures. Any matter that does not have a uniform and unchanging composition is a mixture. So some of the particles that make up substances are different from some of the other particles that make it up. So when you look at something and you can see all the different things that make it up, then that's obviously a mixture. It's not uniform. It doesn't all have the same composition. So think about like salsa. When you look at salsa, you can see the tomatoes, you can see the peppers, you can see the onions. They're all different. You can see that they're all different. And not only can you see the different parts, the salsa from the top of the jar and the salsa from the bottom of the jar may not be the same, especially if you get the chunky salsa. Sometimes the chunks go down to the bottom. You mix it up, the chunks are at the top. So you have to be looking at it. It's not the same every single place in the single container. And salsa from one company and salsa from another company, they're both salsa, but they may have different compositions. They are mixtures. Okay. A sample of a mixture from one place may not be the same as a sample from somewhere else. So that's why whenever you're watching those crime scene shows like CSI and stuff like that, when they can take a sample of dirt and analyze it chemically and they figure out that it came from this certain location, well, it's because they've tested dirt from that location and it has the same composition as the dirt on the person's shoe, and so they must have been from the same place. What that means is that dirt from your yard and dirt from my yard are going to have different compositions, because dirt is a mixture. It has a different composition. So if you can compare the compositions, then it's a pretty good chance that they came from the same place. That's how crime scene investigators are able to trace where somebody was based off of sampling other things. It's not quite that simple, but mixtures are also divided into two categories. So there's two different ways of classifying mixtures, just like there's two different ways of classifying substances. Heterogeneous mixtures and homogeneous mixtures. So again, matter, substances, elements, compounds, or a mixture is either heterogeneous or homogeneous. So heterogeneous. Hetero means different. So a heterogeneous mixture is one in which the particles of the different substance that make it up are relatively large and can be easily distinguished from one another. When I say relatively large, I mean compared to the size of the atoms. Most of the time we're going to talk about heterogeneous mixtures as things where you can visibly see the difference. Like salsa, you can look at salsa and see all the different parts. A salad, you can look at a salad and see all the different parts. They're easily distinguished from one another. If you have sand mixed with water, so you have dirty water, you can look at it, and even though the sand particles are small, you can still see the sand particles different from the water particles. So that's a heterogeneous mixture. There are two kinds of heterogeneous mixtures. We have things called colloids and suspensions. So colloids and suspensions are both types of heterogeneous mixtures. Now a colloid are heterogeneous mixtures that do not settle out. So when you mix them together, they stay mixed. They're a heterogeneous mixture where the particle sizes are relatively large, but when you mix them, they stay mixed together. An example of that is like if you put a few drops of milk into water, the particles of milk are much, much larger than the particles of the water. This is not an exceptionally great example because they cannot be seen easily with your eye, but when you mix a little bit of milk with the water, it will stay there, and so you're going to have that cloudy water, and it's going to stay that cloudy white color constantly. Now, a way that you can identify colloids is that they scatter light when it passes through them. That's called the Tyndall effect. So let's say we have smoke filling up a room and we shine a laser through it. You can see the laser, the beam of the laser. You can't normally see the beam of the laser because, well, you can just see where it hits the wall or hits the ground. The way you see the whole beam is as it passes through the colloid, the particles in the air, it will get scattered. So if you were to shine a laser through milk and water mixture, then you would see the laser beam passing through it. It is a colloid. A suspension is a heterogeneous mixture that will eventually settle out. Now, eventually could be a few minutes, eventually could be a few hours or days, but it will eventually settle out. So let me go back. A really good example of a suspension, that sand and water that I was talking about and dealing with earlier, if you mix the sand up, then it's going to be all mixed up, but if you let it sit there, eventually the sand will all settle to the bottom and you'll have clear water at top and sand at the bottom. Orange juice is another really good example of a suspension. If you've ever looked at an orange juice container, you see that it always says shake well before serving, and it's because it settles. And whether you have pulp in the orange juice or not, but if you have orange juice at home, I encourage you to test this. Is pour a glass of orange juice and then just let it sit on the table for 30 minutes to an hour or so, and then come back and look at it and observe the difference between the top of that cup of orange juice and the bottom of that cup of orange juice. Look at the color difference, because the orange juice actually settles toward the bottom, and you're going to be left with more watery stuff at the top and more concentrated orange juice down at the bottom, because the particles that make up the orange juice actually are a heterogeneous mixture that is going to settle down to the bottom. It is a suspension. So matter is either a substance or a mixture. Elements are on the periodic table. Compounds are made up of elements. Heterogeneous, and then you have mixtures, which are either heterogeneous. You can see the different parts of the mixture. The parts are relatively large. Heterogeneous mixtures are either colloids or suspensions. And then we have homogeneous mixtures. All right. A homogeneous mixture is one in which the particles that make up the mixture are too small to be easily distinguished from each other. Oftentimes, even under a microscope, you can't tell the difference between the parts. Homogeneous mixtures often look like pure substances to the naked eye. The most common form of homogeneous mixtures that we are going to work with are called liquid solutions and alloys. Now, liquid solution is a homogeneous mixture in which one substance is dissolved in a liquid. So here's an example of that. Let me see if I can make this bigger for you. All right, so this is the pure substance, the compound copper chloride. This is copper chloride dissolved in water. It's mixed in water. So when you have just the crystals like this is a compound. If I mix the compound with water, I now have a solution of water. It's a liquid solution, a homogeneous mixture of the copper chloride and water mixed together. So solutions are homogeneous mixtures. We're going to talk about solutions a lot in chemistry. In fact, almost all chemistry that we do is done while the chemicals are mixed in water in solution. So this is a very big deal. We're actually going to do an entire unit on solutions later in the year. So they are homogeneous mixtures. An alloy is a homogeneous mixture of solid metals. So if you want steel, the way you get steel is you take iron, you melt it down, and then you take a few other metals and carbon and a few other things, and you melt them down and you mix them all together while they are liquid, while they're melted, and then you let them cool down and turn back into a solid. But while they're mixed, they are a homogeneous mixture. That is what an alloy is. An alloy is a homogeneous mixture of metals. And the way you make an alloy is by turning them into liquids first. All right, so this is the full breakdown of the classification of matter. So matter is anything that has mass and volume. Matter is broken up into either substances or mixtures. Substances are uniform in composition and can be either elements or compounds. Elements are found on the periodic table. Compounds are made up of elements. All right, let me move my picture up here a little bit so you can see the bottom of this. All right, so elements are broken up into three categories. We'll talk about this when we discuss the periodic table later. Elements are either metals, nonmetals, or metalloids. The vast majority of elements are metals. Compounds are either ionic or covalent. We're going to spend lots of time talking about this in a few weeks. So that's that. All right, so that's substances. Matter can also be a mixture, which is a combination of substances that does not have a uniform composition. They're either heterogeneous or homogeneous. Hetero meaning different, so heterogeneous, you can see the different particles. The particle sizes are relatively large. They are either broken up into colloids or suspensions. Colloids will produce the Tyndall effect and scatter light. They do not settle out. Suspensions will settle out eventually, and you can see the different stuff. You have homogeneous mixtures. Homo meaning same, so they look the same type. So homogeneous are either solutions or alloys. A solution is typically a mixture. Most of the time that we're going to deal with solutions, they are things dissolved in water. But that is a solution, is a homogeneous mixture, and alloys are mixtures of solids, usually metals. So that is the basic classification of matter, and now it is time for you to move on to doing your assignment. Now you will get the next portion of the notes later.